Today we're going to be working on Leetcode question number 310, minimum height trees. A tree is an undirected graph in which any two vertices are connected by exactly one path. In other words, any connected graph without simple cycles is a tree. So given a tree of n nodes labeled from 0 to n minus 1 and an array of n minus 1 edges where edges of I is equal to like AI, BI indicates that there is an undirected edge between two nodes AI and BI in the tree. You can choose any node of the tree as a root. When you select a node X as the root, the result tree has height h. Among all possible rooted trees, those with minimum height are called minimum height trees. Okay, we're going to be returning the list of MHTs, root labels. You can return the answer in any order, and the height of a rooted tree is the number of edges on the longest downward path between the root and a leaf. Okay, so yeah, over here n is equal to 4 and these are the edges between 1 0 1 2 and 3, and the answer is gonna be 1. So and over here the answer is gonna be equal to 3 and 4. um, okay okay so the algorithm is gonna be like, first of all we're gonna be creating the tree, and then we're gonna be removing all the leaves until we are left with one or two uh, nodes. That's gonna be the algorithm which we're gonna be doing, which we're gonna be implementing. So again, create the tree, as we have been given the total number of nodes and the edges. Once we are done creating the trees, we're gonna be looking for the leaves, and we're gonna be removing the leaves one step at a time. All the leaves are gonna be removed, and then we'll see to how many total number of nodes are there. Uh, and we're gonna keep doing it until we are left with only one or two uh, nodes. So those are gonna be our minimum height trees. Okay, so sanity check would be, what if there is only, if the total number of nodes is just one? In that case we're just gonna be returning, because we are returning list of integers, we're gonna say uh, singleton list with value 0. If we have been given one node, that's gonna be the result, like that's gonna be the node which we're gonna be have the minimum height. Okay, then we're gonna be looking for adjacent, um, like for every, like it's gonna be a list of adjacent nodes. So it's gonna be a list of set of integer, oops, integer, we're gonna call it a, like adj for adjacent nodes. Let's call it new array list. So again we're gonna go through, we know that how many sets are there gonna be, total sets of there gonna be, that's gonna be the total number of nodes, and I is equal to 0, I is less than n I plus plus. So for that we're gonna say that you can, if in the adjacent uh, list, you can just add, every single time you can add a new set. Looking good. Now we're going to be creating this tree by looking at the edges. For every edge, and an edge is going to be just two-dimensional, like an array, telling us the indices of, like basically giving us two nodes. So it's going to be one-dimensional array. Okay, edge, inside the edges, So every single time you're gonna say that adjacent dot get the value of that edge uh, at 0th index, right? And then add uh, that edge at index 1. So we are saying that take the first node and add the second node as an adjacent node to it. Okay, that's one thing. And then we're gonna do the same thing to the second node too. Adjacent dot get the edge at first and add edge 0 to it. So again, we are saying that 1 if 0 and if like there are 4 and 5 are one of the edges, we're just gonna say that fourth adjacent node is the fifth one and the fifth adjacent node is the fourth one. Okay, once we create that tree list of integer leaves, now we need to figure out what the leaves are. For that we're gonna say array list. Okay, uh, okay, so in order to calculate the leaves, all we have to look for we have to look for all the adjacent like the entries in the adjacent ones, and like if the size is 1, we're just gonna say that this is a leaf, and so we're gonna be adding it to the leaves list. So for int I equal to 0, you can just use n for total number of adjacent ones because they are exactly the same. So we can say that if the adjacent dot get that I and the size of that thing is equal to 1, we're going to be adding it to the leaves. And at this point, after this for loop, we'll know how many leaves how many and what are the leaves we have. Okay, so while our n is greater than 2, we're gonna keep doing this. First thing is that we wanna update our n, right, by the leaves size. So we wanna remove those many leaves, because every single time we're removing the leaves, so we're gonna update our n. Okay, and once we will be done with removing the leaves, we're gonna have another variable called new leaves, just like that, new array list. Okay, we're gonna go through all the leaves. I'm gonna go through all the leaves, and j is equal to, so, and we're gonna say adjacent dot, so I over here is a leaf, we know that. We can get it in the adjacent one, and then we can have an iterator, because one adjacent can have multiple adjacent nodes, so we're gonna need an iterator for that. Dot next. Okay, and while we have this adjacent dot get of j, the iterator, we're gonna keep removing it. Oh, keep removing the I. I'm gonna keep removing I, and then if we are left with 1, we're just gonna add it to the new leaf, right? If the adjacent dot get of j dot size is equal to 1, we're gonna add it to the new leaves. I'm sorry. So yeah, so once we come out of this for loop, we can actually just uh, set the leaves to the new leaves, and then in the end, once we come out of this, we can just return the leaves. As I said, there can only be one or two MHTs. That is wrong. Looking good. And it cleared all the test cases.